So before I get started, I want to talk a little bit what I mean by when I say residual trust. It's a very simple concept. It's simply the historical reputation of a domain that's implicitly transferred with a change in ownership. And this residual trust can be either positive or negative, depending on whether the historical reputation of that domain was good or bad. And this has a number of different security concerns that result because of this. So let's look at a couple examples of those. I'll start out with an example of an expired Nameserver domain. So in this case, there was an educational institution called Benedictine University. They were using a third-party domain for one of their secondary name servers. At some point, this domain was actually allowed to expire. So what's the big deal here? Well, that domain was subsequently re-registered by an SEO company that wildcarded the MX record. So this meant that all the emails that were sent to addresses that domain were getting sent to this SEO company. And this is particularly problematic given that some of these email addresses were for students, and students are protected by certain privacy laws like FERPA. An even more challenging aspect of this was a particularly difficult problem to diagnose because it was a secondary name server. So this meant that the emails were only getting forwarded to this SEO company intermittently. It wasn't constantly happening. So clearly that's not a good thing, but it actually gets worse. So we also see a case where we looked at the email addresses used as the point of contact information for regional internet registries. And these email addresses were actually being used as trust anchors. And what I mean by that is they were being used to verify that you were who you were so you could log into the login portal and administer the CIDRs that you had control of. So we actually found that there were hundreds of these email addresses that were under expired domain names, and these were available for immediate re-registration. So what this meant was that anyone could go and buy one of these domains, stand up their own mail server, go to the login portal, and request a password reset. This meant you could log into the portal with your new credentials, and now you could make unauthorized changes to IP allocations. Clearly, this isn't something that you want happening on the internet. But that's not all. We also evaluated another case where we looked at approximately 41,000 plugins from the Mozilla store. And when we analyzed these plugins, we saw that they reached out to about 3,000 unique domains for all of these different plugins. And about 5% of those domains were actually expired. So again, we have another problem here where we had a problem where anyone could go and re-register one of these domains. And some of these plugins had tens of thousands of installs, and after registering this, they could use that domain to request a password reset on the developer account and now push down their own updates to end-user browsers. So in essence, you kind of got a browser botnet for the price of a domain. But it doesn't just affect user-level software. We've seen the case where it affects repositories used by operating systems for updates. So there was a popular third-party repository called debianmultimedia.org that was used for obtaining multimedia applications that were outside the license that Debian wanted to offer. And per the request of the Debian maintainers, they wanted more separation between, so it didn't look like they were endorsing this third-party repository, so they asked them to change the name. So they registered a new domain called debmultimedia.org and let the old domain expire. Well, that old domain was subsequently re-registered by another party that was unknown to the Debian community. So again, what's the problem here? Well, the purchaser could have used that domain and stood up their own repository to push down updates for system packages, including the kernel or even base system software. And while it's true that there are protections in place like key signing to protect against unauthorized repositories from pushing updates to the system, it's still possible for that new owner of the domain to go to the Internet Archive, stand up the old page exactly as it was, and update the keys. So any new users going from how-to tutorials or other references on the web to that website would just use this new malicious repository. So we looked at a couple examples of some of the different types of problems that this residual trust can cause when it's abused. But one other question that remains is, how big of a problem actually is this? So we performed a long-term study over 6 years where we tried to analyze just that. And we used 3 different data sets. The first is a data set of expired domains. And this was collected since 2008 all the way up through 2015. And it contained approximately 180 million expired domain names over that period of time. So the next data set we used a malware domain data set, and this had a number of domains that were being used by malware at some point in time, and this was collected since early 2009 through July 2015, and we saw about 6.1 million unique domains in this data set, and these were domains that were likely being abused. And the last data set is a more human-curated list of domains that are likely being abused, and this is a blacklist domain data set. And we collected this since 2009 up through mid-2015, and this contained approximately 320,000 unique domains. So this is a table that shows the relationship between these different data sets. And we discussed these relationships more in the paper, so I'm not going to go into all the details of this table. But what I will look at is I want to call attention to a couple different numbers in this table. The first is this is the intersection between the expired domains and the malware domains. So these are domains that could likely be considered candidates for residual trust abuse. And we saw that there were about 300,000 of these domains in our data set here. And this was about 5% of all malware domains were expired at some point in time. Additionally, when we looked at the intersection between the blacklists and the expired domain list, we saw that there were about 100,000 unique expired domains in this data set, and that this was about almost a third of all public blacklist domains had expired at some point in time. So some of you might be saying, well, this raises another question. When did the abuse happen? Did it happen before or after the expiration? If they were abused before the expiration, this likely wasn't a case where they were abusing any trust in the domain. But if they were abused after expiration, this means that there was some residual trust associated with that domain name that they were likely abusing. And what we saw was that there were about 263,000 unique total abusive domains for blacklist and the malware data set. And this meant that almost 90% of the domains that were being contacted by malware that had expired were only contacted after the domain expired. So these were likely candidates of residual trust abuse. Similarly, about 10% of the blacklist domain expired were abused only after expiration. So again, these are other likely candidates for that residual trust abuse. So another question is this we saw that there were a fair number of domains that were being abused, but is this a growing problem? So I want to highlight one thing about this particular figure, and that's that this only shows domains that were abused after expiration. So any domains here were abused only after expiration, and that's why they're above the diagonal. On the left-hand side here, I want to highlight that this is showing domains that were contacted by malware only after expiration that had higher Alexa ranks. So what we observed is that there appear to be domains that are even fairly popular that expire and then subsequently might be re-registered by malware and being contacted for abuse. And on the left-hand side, these are the domains with lower Alexa ranks that were contacted by malware after expiration for abuse. And what you'll notice here is that as you move up towards the top right, you'll notice that the plot is getting a little bit denser. And when this happens, what we're seeing here is that there are more expirations, there are more domains being abused after expiration in more recent memory. So this is a trend that seems to be growing. In fact, to highlight this in numbers, we saw that between 2009 and 2012, there were only about 6,000 domains that were abused after expiration. But this doubled in 2013 alone to 12,000. So you might be saying, well, okay, this is malware. This is a malware data set. Malware doesn't always contact a malicious domain. Some of these might be benign domains that malware is contacting, and that's what we're seeing here. So we actually looked at this same graph, but for the public blacklist domain. And remember, the public blacklist are human-curated lists, so these are less likely to have the benign domains that are seen in the malware data set. And what you'll notice is you see the same kind of trend here. We see this growth. And again, in numbers, between 2009 and 2012, we saw 800 expired domains in the blacklist that were then used for abuse. That number jumped to 9,000 in 2014 alone. Large increase. This seems to be a problem that people are increasingly exploiting. So how do we even go about finding some of these changes? Well, we can look for expirations, but that's not the only way that a domain can change ownership. So we actually built a lightweight algorithm called Alembic. And this lightweight algorithm helps identify potential ownership changes using only DNS. And one thing to keep a note about this algorithm is it's not a fully automated detector. So it helps locate these events, but it's not a classifier or anything of that nature. And again, I want to highlight it only relies on DNS components to compute a change of ownership score, which is how we rank likely ownership change events. And it does not rely at all on whois information. So some of you might ask, well, why not whois? Who's used whois here? Who's tried to collect whois at scale? Who hates your life because you tried to collect whois at scale? Exactly, yeah. So whois is an awful thing to try to collect at scale. Different registrars have different policies about how many queries you can collect at any given time. Whois can lie, and it can lie in unexpected ways. And once you've collected it, it can be challenging to parse. So we avoid all that with Alembic. So how does Alembic work? Well, we use a window, and within that window, we compute several different components. One is we look for infrastructure changes around a given point in time. So we measure the changes in the host that a domain points to within this temporal window. So if we see big changes in infrastructure, this could indicate that they moved to a different host, or it could indicate that there was an ownership change here. But this isn't, by itself, this isn't a good enough indicator for a change of ownership. But that's why we also look for things like lookup volume distribution changes, which might indicate that the service that is associated with that domain has changed over time, or something has changed about the domain, maybe indicating an ownership change. And then lastly, we look at start of authority records. And these are particularly interesting because these are records that don't often change. So when you see a change to a start of authority record, this often is a very good, strong indicator that a change of ownership has actually occurred. So how effective is our Alembic algorithm? Well, one of the challenges that we faced was the sparsity of passive DNS data. So due to this, we didn't always have an observation immediately near an ownership change event. So one of the questions you might ask, what you'll notice here is that we see that about 75% of the domains were within 10 days. So this means that if we flag a domain as likely being a candidate for ownership within 10 days of when it actually expired, our algorithm was doing pretty good given the sparsity of passive DNS data. So what does our algorithm generate? Well, what we see here on the right-hand side is that below the red line, these are cases where we indicated that a domain was had likely changed ownership given a higher score, indicating a likely ownership change. And we'll notice that a majority of the lighter blue dots are below this red line, which is exactly what we expect to see. We also see here that as the window size increases, we get better at making identifying these likely ownership changes. And so this is really good, and this is a really lightweight algorithm. So using our algorithm, we actually made a number of different discoveries. So some of the stuff that we found were just simple domains where they were abusing the positive residual trust. So these were just whitewashed domains. They were previously benign domains that had subsequently registered by malware and now were being abused. And we verified these manually. But another interesting case is we've talked a lot about abusing positive residual trust. But the other case that we mentioned earlier on was that there was also negative residual trust. So one of the domains that our algorithm turned up was an expired APT domain. So this is particularly interesting because these can be hard to find, but this particular domain was available for immediate registration. So we actually registered it and started collecting traffic from this domain. And we started immediately getting requests from a Taiwanese research facility. So what we saw here was that for the low price of a domain registration, you could buy your own APT. Pretty cool. Just want to summarize kind of what we've talked about briefly here. First is that we identified this idea of residual trust, and we saw that it causes a number of different problems that sometimes seem like they might be caused by different things, but it's the underlying cause was residual trust. Next was we looked at a long-term study of expired domain abuse dating back to 2008, and we observed not only that this residual trust abuse does actually occur, but that it actually seems to be on the rise. And then last, we proposed a lightweight algorithm to help us identify these potential ownership changes using only DNS. This meant we got to avoid using whois, which we said can lie and has a number of difficulties, and the results are actually fairly good. And the last thing that these results kind of indicate is that we might need better policies to help address this problem at the registrar or registry level, and maybe there are other considerations beyond just technical solutions that we should be aware of. And so with that, I'll open up for questions.
Hi, John Spring, UCL. So I know you're not going to tell us what blacklist you used, but I know from our other work that there are a bunch more domains on blacklists than 300,000, so I assume you used a couple. How do we know that the increasing trend isn't the people who curated your blacklist getting good at detecting something that's correlated with trust abuse rather than trust abuse actually increasing?
So I think one of the indicators there is that we're not just seeing this with the blacklist, right? We had two different cases. We had malware and we had blacklists. So either they're both happening by chance and seem to be growing, or there seems to be this concerted effort by people trying to do abuse to take this residual trust and abuse it. And one of the reasons why that seems attractive is that if you look at how reputation systems might work on a domain, unless that domain is retired from the reputation system or something changes, then picking up one of these old domains has the benefit that you might evade existing whitelist or blacklist solutions until they remove that off. We actually had an interesting case where we talked to people at Facebook, and they mentioned that they've had cases where they have things on on one of their spam lists, and their spam lists only get updated so often, but they're not great at retiring things off the spam lists. So they have cases where people will complain that they're being censored when really they just bought a domain that was previously used for spam and the spam list hasn't been updated. The same would apply for blacklist and other things for malware domains. So if they haven't been removed from like a whitelist, then if I bought one, I'm going to skirt detection just because they look for it on the whitelist.
All right, cool, thanks.
Tudor Dimitris from the University of Maryland. Very interesting work. I'm just curious, when you say that the malware contacted these domains, what was the purpose? Was it a CNC? Was it to drop malware? What was it doing?
I mean, it could have been any of those types of purposes, right? So we collected these domains from dynamic execution traces. So we don't, since we had so many domains, it's hard to know exactly what all of them were used for. But what's interesting here is when we looked at the intersection, we saw that a number of them were actually just making queries to expired domains. So they were doing something there, and since it is malware, there's potential for abuse there. So why are so many malware samples contacting domains that are expired? And I think that's kind of the interesting thing there. And I think that alone that's something, but with the blacklist, that kind of helps indicate that these are hand-curated indications of abuse. So it seems like there's something there.
Cool. Thank you.
All right.
We have time for some more questions. Is there any other questions? Okay, let's thank the speaker. Okay.
Yeah, if we have time. So I was also curious, how easy do you think your Alembic algorithm would be to evade?
So that's a good question. So one of the things that's nice about the Alembic algorithm right now is we're using infrastructure properties on the internet. So these are things that, unless you make a concerted effort to change this, in some cases it might even be hard. Given the infrastructure, we see that malware often uses similar infrastructure. So some of these, like that, the infrastructure changes in the SOA records, these are things that aren't frequently changed. So if they mess with that, you could possibly evade it. But since it's something that's infrastructure related, it's probably more challenging.